Hi guys, in this video we are going to be solving polynomial inequalities. So we're going to start with a trinomial here. It's second degree, so it's quadratic. So let's first think about maybe what the graphs of these look like. So especially a quadratic is going to be a U shape, right? It might be facing up, or if it's negative in front it might have gotten flipped, so it may be like this. Most of the ones that we're going to deal with today are going to be quadratic. So if you think about it, if we're talking about where it's greater than or equal to 0, like where is this function greater than or equal to 0, it's going to be any part that's above the x-axis. So let's say, for example, this one looked like this. These parts that are above the x-axis, those are going to be positive, which means they're greater than 0. But then this middle piece right here that's hanging below the x-axis, that's where the function is negative, and so those are the ones that will not be part of our solution set. So that's kind of what's going on graphically. So I guess if it's all, like if it were turned upside down and it's all below, and it said greater than 0, it would not have a solution, right? But if it said less than 0, it would be all of it. It would be the entire function would be. So it would just be negative infinity to infinity. If it only touches the x-axis and then turns back around, it's basically positive everywhere except for that one point where it touches, and that one point where it touches is not negative or positive, right? So if it said equal 0, it would include that point. If it just said greater than or less than, it would not include that point. So let's just go ahead and look at some of these. So notice here, though, that these are the spots where it's crossing the x-axis. These are the points that it is going to tell us some information. So that's our first goal here, is to find those x-intercepts, which is the same as the solutions when this equals 0. So basically, we want to take our quadratic, and we want to make sure one side is 0 first. And then we're going to factor it using x factoring, because that helps us find these x-intercepts, which are also the solutions when it equals 0. So let's go ahead and do that. A is 1 and C is negative 24. So if I multiply those together, A times C, I get negative 24. And then B is negative 5. So I'm looking for two numbers that multiply to negative 24, but add to negative 5. So I think negative 8 and positive 3 are going to work there for us. So now what we need to do is write it in factored form, which would just be x minus 8 times x plus 3. And then to find those places where they cross, to find the solutions when it equals 0, we would take and find the x value that makes each one equal 0, right? So that would be positive 8 and negative 3. So I'm going to draw a little number line here, and I'm going to circle those two values. So here I've got 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. Now notice that my inequality has greater than or equal to 8. I'm actually going to erase that. And so we want to have a open circle. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to change colors. It just makes it look a little better. Okay, so I'm going to circle 8 with an open circle. And I'm going to do the same on negative 3. So here's negative 3. And I'm going to circle it with an open circle. Oh, just kidding. I'm going to circle with filled in circle because it said greater than or equal to. And now, since it's not really obvious here, like it is when it's a linear inequality like we did before, we couldn't just get x all by itself on one side. What we need to do is check each of these intervals to see which ones are positive and which ones are negative. Since we already know that this is a quadratic and it's crossing in two places and the coefficient out front is positive, we kind of already know that the two ends are going to be the positive, the greater than or equal to 0, so those are the parts we're going to end up shading. But let's just go ahead and go through the process anyway. So basically what I want to do here is I want to check each interval, and the intervals are the parts that I just kind of broke up with these values I put here. So I'm doing these dotted lines. So this is interval 1, this is interval 2, and this is interval 3. So interval 1 goes from negative infinity to negative 3. Interval 2 goes from -3 to 8, and interval 3 goes from 8 to infinity. So basically everything in in interval 1 is going to be the same. It's either going to be greater than or equal to 0, or it's going to be less than 0. And the same thing goes for interval 2 and 3. So if I can just check for each interval to see if the value is positive or negative, that's going to help me determine which parts of my number line are greater than or equal to 0, or my x values. So what I'm going to do is I'm going to choose any x value within interval 1. It could be -4 or -5 or -652. As long as it's less than -3, it will work. So I'm going to go ahead and put -4 into my function. So I'm replacing x with -4. So remember, if you're squaring a negative, make sure you put that in parentheses in your calculator so you get the right value. If you don't put the negative within the parentheses, it's going to square 4 and then add the negative, which will give you the wrong thing. So -5 times -4 and then -24. So 4 times 4 is 16. -5 times -4 is +20, and then -24. So that gives me 36 minus 24, which equals 12. Well, 12 is greater than or equal to 0, right? So that's true, which means I want to shade this section of my number line. Now, if I choose a value between -3 and 8, like 0, it could be any of these, but 0 is really easy to calculate, so I'm going to use 0. I plug it back in here, I would get 0 squared minus 5 times 0 minus 24 is greater than or equal to 0. So that's 0, 0. So it would just be -24 is greater than or equal to 0. Well, -24 is not greater than or equal to 0. So this section right here is false, and we're not going to highlight that part. For interval 3, I have to choose any number bigger than 8. So I could do 9 or 10 or 400. Let's just do 9. So if I plug 9 in here, I'm going to get 9 squared minus 5 times 9 minus 24. 9 squared is 81. 5 times 9 is 45. And then minus 24. So this is the same as 81 minus 40, 69. So it is still positive. That is greater than or equal to 0. So this section is true, so I would highlight this. So I know that for all the x values that are less than -3 and greater than 8, I'm using this for an example, even though it would be more like that, right? So -3, 8, it looks like this. It's positive or greater than 0 on the ends, and that's what our number line's representing here. So my interval notation would go from -infinity to -3, and then also 8 to infinity. Okay. So my solutions come from either -infinity to -3 or 8 to infinity. So there's the interval notation. Okay, so let's try another. So I'm going to factor again using x factoring. It's already got 0 on one side, so I can go ahead and get started. So a is -1 and c is 10, so multiply those to get -10. And then my b is -3. So I need two numbers that multiply to -10 but add to -3, so I'm thinking -5 and 2. I've got to go ahead and factor. Remember, I'm looking for those critical values, so that's when this equals 0, even though my inequality says less than 0. So this would be x minus 5 and x plus 2. But remember, I always need to divide by a, and a is -1, so that will change things here, so I need to make sure I do that. So x plus 5 times x minus 2 equals 0. Right? 2 divided by -1 is -2. -5 divided by -1 is +5. So the two solutions, or the two x-intercepts of our quadratic here, would be -5 and 2. So then I'll draw a number line, and I will circle those values. So here's -5, and here is 2. Now I've circled these with open circles because my inequality right here just says less than, it doesn't say or equal to, so I know they need to be open circles. That just broke my number line into 3 intervals. So the first one, interval 1, the value that I choose has to be less than -5. So I could do -6 or -7 or -10. Let's actually do -10. So I already have a negative here, and I'm plugging in -10 for x. So it would be negative and then -10 squared. Minus 3 times -10 plus 10. So -10 squared is 100, and then the negative out front would make it negative 100. Negative 3 times -10 is positive 30, and then plus 10. So this gives me negative 100 plus 40, which equals negative 60. So is negative 60 less than 0? Yes, it is. So that one is true, which means I'm going to highlight this section. Interval 2, I can choose anything between -5 and 2. 0 is always easy to calculate, so I'm going to put a 0 here. So negative 0 squared minus 3 times 0 plus 10 is less than 0. So these both go away because they're zeros. 10 is not less than 0, so this one's false, so I don't highlight it. Okay, interval 3, anything bigger than 2. So let's put 3 in here. So negative 3 squared minus 3x plus 10. So on this one, see this one's different. 3 was positive, so we're going to square 3 first, and then we're going to add that negative on. So this would be negative 9 minus, whoops, I forgot to put my 3 in there. So minus 9 plus 10. So that would give me negative 18 plus 10, which equals negative 8. And negative 8 is less than 0, so that one checks out. This is true, so I would highlight this section. Okay, which means my intervals go from negative infinity to -5, or from 2 to infinity. Okay, so there's my solution set. Now, think about that. Since I have a quadratic again, right, I know that it's going to cross at -5 and positive 2. Those are the 2 points it's crossing. I know because it's negative out front that it's been flipped over, so it looks something like this. So see how it's positive here and it's negative on the ends? That's what we just showed with our inequality. Okay, so let's just do one more example. So I have negative 3x squared minus 22x plus 16. I do want one side to be 0, so that's good. Just make sure that if there's anything over here, you move it to this side before you begin. 3, 22, and 16 have no common factors, so I'm just going to go ahead and x factor. A is negative 3, and C is 16. So 16 times 3 is 10, 20, 30, 42, 48. So it would be negative 48 because I've got negative 3 times 16. And then B is negative 22. So I'm looking for two numbers that multiply to negative 48, then add to 22. So let's see, we got 2 times 24. So let's do that. 2 times 24, negative 24 and positive 2. That will work for us. So let's factor. Remember, we want to find those values when this equals 0, and then we'll use our inequality when we test our intervals. So we've got x plus 2, and we've got x minus 24. Remember, a was negative 3 here, so I need to divide each of my factors by a. So this would be x minus 2/3 times x plus 8. And if I'm setting those equal to 0 and solving, my two solutions that x will equal are 2/3 and negative 8. So these are the places where it crosses the x-axis. But I'm just going to draw a one-dimensional number line here. So I've got 1, 2, 3, 4, 5, 6, 7. Oops, I didn't make my number line long enough here. 8. So here's 8, so I'm going to circle that with an open circle because my inequality doesn't have an equal sign. And then, whoops, I accidentally put a 2 on the bottom. So 2/3, that's, here, if this is 1, 2/3 is about right there. Again, with an open circle, right? So that just divided my number line into 3 pieces. So I'm first going to check this one has anything less than -8 will work. So I'm going to choose -10 just because it kind of plugs in easier. So -3 times -10 squared minus 22 times -10 plus 16. So that would be 100 times -3, which is -300. Then we have a positive 220 and a positive 16. But that result's going to be negative, right? Because -300 is bigger than these two added together. So a negative number is less than 0. That's true. So I would shade this part of my number line. Okay. This middle piece, I can choose anything between 2/3 and -8. I'm going to put 0 in, again, because it's easy. These two just go away, and I just have 16 is less than 0, which is false. So I won't shade the middle. And then I do this anything that's bigger than 2/3. So let's actually just plug 1 in. So -3 times 1 squared minus 22 times 1 plus 16. So 1 squared is 1. -3 times 1 is -3 minus 22 plus 16. So -25 plus 16, that's coming out negative, right? And negative is less than 0, so this is true. So these are the ones that are less than 0. It would go from -infinity to -8, or from 2/3 to infinity. Okay. So go ahead and give some of these a try. If you have questions, please let me know. I'd be happy to help you, and we'll see you next time.